this video, we'll talk about how to graph linear equations in two variables, focusing on vertical and horizontal lines. So let's first recall that a linear equation in two variables is of the form ax plus by equals c, where a, b, and c are real numbers, but a and b are not both 0. Solutions to this equation are ordered pairs in the form x, y, and when graphed, the solutions form a line. So in the definition, we see that a and b are not both 0, but that means that one or the other could be 0. So the question is, what happens if either a is equal to 0 or b is equal to 0? Let's first look at the case where a is equal to 0. Our equation is now written in the form by equals c. Remember, b cannot be equal to 0 if a is, so b is some real coefficient that's non-zero. So for example, we could have the equation 3y equals 12, which we can solve for y by dividing by 3 on both sides, and that gives us the simplified equation y equals 4. Let's think about some solutions for this equation. Remember, this is an equation in two variables, so we're still thinking about ordered pairs, even though we only see one of the variables in the equation. So since our equation only has y in it, that means that it does not depend at all on the value of x. This statement tells us that y equals 4, y is 4, and since x is not there, x can be anything we want, but the y has to be 4. So we can let x vary, and I just chose some arbitrary values for x. So I chose 1, 5, 0, -2, -1, just pick some values for x. But since there's nowhere to plug them in, and we know that no matter what y is equal to 4, the y value is always 4. So here are some ordered pairs. 1, 4, 5, 4, 0, 4, -2, 4, and -1, 4. So we're going to go ahead and plot those on the coordinate plane and see what happens. Alright, so here I've plotted the ordered pairs that you saw on the last slide. So I had 1, 4, 5, 4, 0, 4, -2, 4, and -1, 4. So I've plotted the 5 ordered pairs that I had chosen, and I see that these points are going to form a line. And like we saw in the first video, you could use those points to gauge where the line is, and then you know the rest of the solutions are found by connecting those points and making the straight line. So if I connect these solutions, I will do so with a horizontal line. And this horizontal line represents the solution set y equals 4. So any point on this line, no matter what point I choose, has a y coordinate of 4. So because the y value is always the same, we'll always get a horizontal line. It'll just depend on the constant will determine where on the coordinate plane that horizontal line lives. So any horizontal line can be written in the form y equals b, where b is just some real number, and we have a y-intercept at the point 0, b. So in the last example that we had just graphed, y equals 4, all of the points have the same height, right? This y value really determines the height above or below the x-axis. So all of the points will form that horizontal line. The y-intercept is the point where it hits the y-axis, which in this case would be 0, 4. All right, so let's look at the second case. So going back to our linear equation, ax plus by equals c, let's look at what happens when b is equal to 0. So the term containing b disappears, we're left with ax equals c. So for example, let's look at the equation -2x equals 10, which when we simplify and divide by -2 on both sides, we have x equals -5. Again, let's look at some solutions for this equation x equals -5. So here x is described as being -5 no matter what, which means the y value can be anything. So I chose some values for y, but no matter which value of y I choose, the x value is always the same, -5. So here are some possible solutions that would work for this equation, x equals -5. Notice the x coordinates are all the same, the y coordinates can be any other real number. Let's go ahead and plot these on the coordinate plane as well and see what happens. All right, so here I've plotted those 5 ordered pairs on my coordinate plane. So I have -5, 1, -5, 2, -5, 3, -5, 4, and -5, -2 all plotted. These 5 ordered pairs have the same x value, so they are equidistant from the y-axis in this case. And if we were to connect these points, we would have a line, but this line is vertical. So this line represents the solutions to the equation x equals -5. Represents all of the ordered pairs that have an x coordinate of -5. Any ordered pair I pick and locate has an x coordinate of -5 and then some other y coordinate. This one that I picked happened to also have a y coordinate of -5. Right, and we'll see that this happens for any equation in this form, x equals and then some number, because the points will all be right on top of each other because you're going the same distance away from the origin or away from the y-axis. All right, so our definition for a vertical line, the graph of a vertical line can be written as x equals a, where a is a real number with an x-intercept at a, 0. So whatever the number is here, that's your x-intercept. That's the place where your graph is going to cross the x-axis. And in this example, this line hits the x-axis right at -5. So -5, 0 would be the x-intercept. So let's take a look at some of these and go ahead and graph them by hand. So for each one, we want to be able to recognize whether or not we have a vertical or horizontal line. So in general, if you only see a y in the equation, it will be a horizontal line, and if you only see an x in the equation, it will be a vertical line. You want to simplify the equation, solve for x or y, before you go ahead and graph. In the first example, we have 5y equals -15. So I have that here. So I want to simplify this. I see that there's only a y, so I'm going to divide by 5 on both sides. And I have y equals -3. Now since there's y only, I know that this is a horizontal line. I know that -3 is the y-intercept. So I'm going to go to -3 on the y-axis. I have my points marked off here, my scale. So I'm going -1, -2, -3 is right here. And since it's horizontal, I could just go ahead and draw the horizontal line right through -3. And this represents all of the points that have a y value of -3. In the second example, we have x plus 7 equals -10. So once again, we want to isolate the variable. In this case, we only see an x, so we're going to isolate the x. So I will do that by subtracting 7 on both sides. So I have x equals -17. Alright, so it's a good thing I didn't put the scale on my axes yet, because I might have to change my scale so that I could find x equals -17. Alright, so 17 is a prime number, so it's not divisible by anything, but that's okay. I can approximate where that lives. I'm going to mark off every 2 boxes and say that it's 5, so 5, 10, 15. On the other side, every 2, 5, -5, -10, -15. And then I could do the same scale on the y-axis. I'll just go 5, 10. It's really only enough to do one number. -5, -10. All right, so I want -17. This is x equals -17, so I have a vertical line. Let me change colors here. So I want a vertical line that passes through the x-axis at -17. So here's -15 on the x-axis. I can approximate. I have about 5 values in between here and here. So let's say it's about here. Call that -17. And then I'll draw my vertical line right through that point. X equals -17. Okay, so again, you might have to change your scale depending on the value that you have, but when you have a vertical or horizontal line, there's really not much to do besides just locate where it hits the appropriate axis using the intercept, and then drawing that vertical or horizontal line through it. Let's go on to the next one. Here we have x equals 0. So this one's a little bit different because x equals 0 is a vertical line, but it has a intercept at 0. So if I think about my x-intercept at 0 would be right here. This is an x-intercept and a y-intercept because it is at the origin. But remember, x equals is a vertical line. So I'm going to draw a vertical line right through that point. And this is one of the few times that we are drawing a line that maps right onto one of the axes. So x equals 0 is the equation for the y-axis. So it's this line that goes right over the y-axis. And finally, our last example, -8y equals 0. We want to solve that for y. So I'll do that by dividing both sides by -8. When I divide by -8, a 0 divided by -8 is just 0. So I have the equation y equals 0, which is similar to the other equation because I have 0, have a y-intercept at 0, but since it's y equals, it's a horizontal line, so I'm drawing a horizontal line right through the origin. So this is the equation for the x-axis. But we're looking at the line that goes right over the x-axis. And that concludes this video.